Hello, class. This is Mr. Parsons here. Just want to take a few minutes to talk to you about mean, median, and mean absolute deviation. So, uh, Ellen asked 10 classmates how many hours they spend on their homework each week. We want to determine the typical amount of time students spend on the homework. So, you want to think about data and statistics. And so, the best route that Ellen should go would be to use the mean or find the average or the median to find out the typical amount of time students spend on homework each week. So mean or median could work in this instance. And so when we're looking at a measure of center, you're trying to summarize the data that you collected so you can be able to analyze and interpret it. And so when we talk about mean, right, we're talking about the average. And so to find the average of your data, you're going to add of your data all of your data together, and you're going to divide it by how many numbers in your data set. Okay, so that's going to be symbolized by the symbol X with the bar over it. With the median, you're finding the middle number. All right. And so for the median, the first thing you have to make sure you do is put your data set in order from least to greatest. And then from there, you want to look at the number that's in the middle. And then your middle number will determine your median of that data set. So as we look, let's take a look. Sergio wants to buy a new set of headphones and looking at two different products. He's looking at Soundbite, he's looking at Tunes. And these represent the customer ratings of each of the brands. And so first we want to look at Soundbites. So this is the customer rating of Soundbite. We want to find the mean and the median of the Soundbite. So I always recommend this, even for the mean. Always put your data set in order from least to greatest. It helps and it makes things a little bit easier to read. So if I look at Soundbite, I'll put these ratings in order from least to greatest. Now I want to go ahead and find the mean. So to find the mean, I add all these numbers up together. And when I add them up together, I get 50. And then I look at the number of numbers in my data set. There are 12 numbers in a data set. So I take 50 and divide it by 12. And that gives me 4.2 because you got to round it to the nearest tenth. So therefore, the mean of this data set is 4.2. So the average rating for Soundbite is 4.2. Now I want to go ahead and look at the median. So I already have my data set in order from least to greatest. I want to find the middle number. Here's the thing. This is an even set of numbers. So there's not one number that's in the middle of your data set. So in the instance when you have an even set of numbers in your data set, what you want to do is look at the middle two numbers. All right. So my middle two numbers is these two fives is highlighted in red. I just add the middle two numbers together and divide it by 2, and that gives you your median for the data set when you have an even set of numbers. So if I add these two numbers together, divide it by 2, then I get 5. So therefore, the median of this data set is 5. Okay, I want to do the same thing for tunes, the mean and the median. So I put these numbers in order from least to greatest. All right, I add them together. That's going to give me 43. Now there are 11 numbers in this data set right here. So I'm going to take 43 and divide by 11, and that gives me 3.9. So the mean of this data set here is going to be 3.9. That's the average rating for tunes. And then let's look at the median. So I already got the numbers in order from least to greatest. Now this is an odd set of numbers. So anytime you have an odd set of numbers in your data set, right, then you're going to have one number in the middle that's clear, and that's going to help with your median. So the number that's in the middle is 4, and so therefore your median, which is your middle number, is going to be 4. So it says what measure of center. So the measure of center we're talking about is the mean and the median, with the best to represent a typical rating. So a typical rating will be a normal rating, all right, a usual rating that you'll get. So if I'm looking at Soundbite, look at the usual ratings. Really a 5 and a couple 4s. But you look, so 4 and 5s are your usual rating. Those are higher because you're looking at between 1 to 5. So 4 and 5, okay, I'm right there. But look at these ones. That's really low. And it's only a few, only 2 out of the 12 that gave a 1 rating. So if I'm looking at a usual or typical rating, if I do the mean, then those ones affect the mean. It lowers the mean. So if I want to look at usual typical rating, then the best measure of center that I will want to use wouldn't be the mean, it will be the median. All right, so the median will be the best measure of center for me to look at for a typical rating for soundbite, because if I do the mean, it's going to be affected by those two ones. If I look at number 4, I want to compare the median and the mean for tunes. So look at the mean for tunes. I have 3.9 and the median is 4. So those are pretty much close together. Anytime that you have your mean and your median like close together, if not the same, it just states that your data is symmetrical. Your data is symmetrical. So that's pretty close. All right. And so it says, which brand of headphones would you recommend for Sergio to buy? Well, let's compare the mean and the median for both. The mean is 4.2 versus 3.9 for tunes. All right, the median is 5 versus the median for 4. And this is talking about customer ratings on a scale from 1 to 5. So the higher the ratings, the better. All right. So it's a higher rating for the mean for soundbite than tunes, and it's a higher rating for the median for soundbite than tunes. So it's recommended that Sergio should get soundbite because soundbite has the higher mean and median ratings than tune headphones. Now let's look at mean absolute deviation. So the mean absolute deviation helps us to look at how spread out your data is, and so you compare your mean versus each data in your data set to see how that number deviates from the mean or from the average. So to find your mean absolute deviation, you got to see how you got to look at the average of the values that deviates from your mean. And so a mean, which is abbreviated as MAD, the closer it is to 0, meaning how close that specific data set is to the mean. So in order for us to calculate, you want to find the mean of the data set first, and then you want to do the difference between do the absolute value of the difference between each point and the mean. Once you do that, you're going to find the average of all of those differences, and that's going to give you your mean absolute deviation. So let me show you what I'm talking about here. We're looking at two high schools, Riga High School and Bush High School, and they're doing a number sense competition, and this is showing the number of minutes it takes for each student to complete a set of problems. So we want to first look at the mean of each data set. So let's look at Riga High School. I always, even if I do the mean, I always recommend that you do the numbers in order for least to greatest. It's just a good practice. And so what I do is I put the numbers in order from least to greatest. I add them all up together. That gives me 81. There's 6 numbers in a data set. So I do 81 divided by 6. That gives me 13 and a half. All right. So the mean would be 13 and a half for Riga High School. That's just the average number that it takes for each student to complete the problem. I'm going to do the same thing for Bush High School. Put them in order from least to greatest. Add them together. That gives me 90. There's 6 numbers in the data set. So do 90 divided by 6. That gives me 15. And so the mean for Bush High School is 15. Now you want to do your deviation. All right, this are the average. So I want to see uh, how much does each data point deviates from my mean. So for Riga High School, what I do is I do 18 minus 13.5, 7 minus 13.5, 14 minus 13.5, and so on. And then I just do the absolute value, meaning each one of those are going to be positive. Same thing for Bush High School. All right, 20 minus 15, 9 minus 15, 6 minus 15, 15 minus 15, so forth. And then once you find the difference, just do the absolute value, meaning all of them are going to be positive. And when I do that, this is what I have. So this is how it deviates from the mean. And then once you do your deviation, you just find the mean of the deviation. All right. So for Rigo High School, when I add all these up together, I get 25. And then 25 divided by 6, because there's 6 numbers, that gives me 4.2. So the mean absolute deviation for Riga High School is 4.2. Same thing for Bush High School. Add my deviations together. All right, that's going to give me 50. and then divided by how many numbers, which is 6, and that's going to give me 8.3. So the mean absolute deviation for Bush High School is 8.3. So I want to compare the mean for each. So the mean for Regal High School is 13.5 versus the mean of Bush High School is 15. So what it's telling me, because this is looking at the number of minutes to take each student to complete a set of problems, Bush High School has a higher average than Regal High School. So it tells me that overall, it takes the students at Bush High School longer to complete the problems than it does for Regal High School. All right. If I look at the mean absolute deviation for each school, then what I see is, all right, I have my mean absolute deviation for Regal High School is smaller than Bush High School. And you want to look, so the closer you are to 0, the closer each data point is to the mean, meaning it's not as spread out. Bush High School has a higher mean absolute deviation. All right, it's about twice as much. So what it's telling me is it's more spread out. It's not as consistent. All right, as Regal High School is, as far as the time it takes for each student to complete a set of problems. Now let's look at number 10. This is the track team, and these are 6 students completing a long jump. This is the for each student, this is how the distance. The student who jumped 2.9 meters got disqualified. Now, Marlise believes removing 2.9 meters will increase both the mean and the mean absolute deviation. Do we agree or disagree? Think about the mean. The mean is the average. So you add each number together and divide it by how many numbers in the data set. Now, 2.9 meters is the smallest distance out of your data set here. So if we remove 2.9 meters from this data set, it's actually going to help increase the mean, okay? But the mean absolute deviation looks at how spread out your data is, all right? So you want to look at how close it is to 0. If you remove 2.9, because that's going to have an effect on the mean, if you remove 2.9 meters, it's not going to increase the mean absolute deviation. It's going to decrease the mean absolute deviation because the rest of the numbers are going to be closer together than it is with 2.9. So we will have to, we can agree that it will increase the mean, but the mean absolute deviation will decrease because of the removal of 2.9, and it won't be as spread out. So just the recap here, we're talking about the measures of center of mean, median, and mean absolute deviation. For the mean, you're just finding the average. You're adding all the numbers up together, dividing it by how many numbers in your data set. For the median, you want to find the middle number, but you want to make sure you put the numbers in order from least to greatest. And then the middle number is the median. If you have an even set of numbers, you're going to have 2 numbers in the middle. Just take those 2 numbers, add them together, and divide it by 2. That gives you your median. For the mean absolute deviation, which shows how spread out your data is, you want to first find the mean of your original data set, and then you want to subtract each number in your data set from the mean, all right? Do the absolute value of the difference. That's your deviation. Do the mean of that deviation, and that gives you your mean absolute deviation. The closer you are to 0, that means the closer each data point is to the mean. All right. So I hope this helps with our understanding with mean, median, and mean absolute deviation.